Hello. Hi, everyone. My name is Shan. I work at the visualization team with Nico. So Nico just introduced deck.gl, and then today I'm going to talk a little bit about this tool we built with deck.gl that help us. It's a web-based tool. It basically helps us exploring geolocation data on a map. And talk about map. When people ask me what I do, like in terms of visualization, what I like to say is, okay, I draw maps. That's a short story. And the longer version is I make tools to draw maps. But sometimes I also make tools to draw maps, as you can see how it goes down. So why do we want to do that? Because location data can encode many layers of information. And by just randomly throwing on a map, sometimes, or most of the times, you don't actually learn anything from it. That's why we need some kind of exploration or web application to help us to better understanding what is in your location data. You know, at Uber, location data is our biggest assets. We have millions of trips happening every day. We have billions of GPS pings on our platform. This is just one example showing how we are doing from our Uber first launch in 2010. We're doing our first trip in San Francisco. And this is showing every single trip throughout the course of 6 years. I think we made our 1 million trip in, wait for it. Oh, it's already passed. We made our 1 billion trip in December of 2015. And then shortly 6 months after that, we made it our 2 billion trip in 2016. That's just in 6 years of time, 2 billion rides in total happened on our platform. I mean, the reason I'm showing this, I mean, not to brag, but it's that I just feel like if I just tell you a sentence of, okay, 2 billion trips in 6 years, you doesn't necessarily get me. You doesn't necessarily know what actually happened throughout the 6 years. Not until you see this interesting map, which is doing stereographic projection of the whole world, seeing actual trips happen throughout 6 years, you get the idea of what it actually means. Same applies to on a city level. You know, when I tell you, okay, 5 million trips per day, you're like, okay, so what does 5 million even mean? But, you know, I will show you just this one image of New York, which is made of all the app activities on our platform in just one single day. You kind of just get it because, you know New York, you know Manhattan, you know why the basic downtown Manhattan is light up because just of the population density. You also know like those 2, 3, I don't have a pointer, but those 2 dots on top, that's the airport, LaGuardia. LaGuardia is the bottom, and then there's another airport over there, and there's one other airport in New Jersey. So when 5 billion as a number turn into this 3-dimensional map, you kind of get the number. The 1-dimensional number was bring to life by just one single image. And let's go into even more layers that map can embed. Let's go into every trip level. Like I love to show this map to people. You might think it's just like a map of San Francisco, but instead, every line or every street on this map is actually made by actual trips on our platform in just one single day. So you probably know San Francisco a lot. You know where in the center, the Soma, where a lot of trip happens, but it also has a lot of high buildings. So we see a lot of like noise, GPS arrows in center of San Francisco. And another map made for New York with the same amount as 1 day of trip. This is Mexico City. Now, if you don't know Mexico City, you're like, why is this, you know, so like a spider net? But the reason why there's a lot of curve roads at the bottom left is because they actually are mountains. So all the roads there are much winding. And just using, you know, just seeing cars following this road, like drawing on this map, you kind of understand the city a lot better. I guess there's someone from France I talked to, so yeah. So this is Paris. I kind of already put the name of the city there, but if you can guess, this is London. And this is Jakarta in Indonesia. This is my favorite, Rio de Janeiro. I had to practice my Spanish. So this is actually my favorite one. You see this bay, and then those rows kind of look like two animals are fighting with each other. And this one is Sydney. And same rules apply, where you see there's a bridge right in the middle that's actually it's a tunnel, and we lose a lot of GPS signals there. That's why the lines are very random. And when we bring all these static trips to life, we made this we made this video called A Day in Life of Uber. This is animating 1 day of trips in London. I'm just gonna be quiet and let you watch it. If they can, I guess they can drive there, but I don't know. I mean, we probably have a lot of GPS errors here, so it's tough. Okay, so at this point, right, you're probably bombarded by all the pretty images that I throw at you, and you're asking me these uncomfortable questions of, so what? Everyone working visualization probably got asked this a lot. You know, at the end of the day, what I hate the most is someone come to me saying, hey, I love the map you did. Can I use it as my screensaver? So if you say that to me, I probably felt like I failed, because I want my maps to tell you a lot more than just a pretty image. I want actually, you know, we make maps just to gain insights from location data. I want you to learn more than just a pretty lines and colors. So, you know, so let me talk to you a little bit about this process of gaining insights. You know, sometimes the process can be very painful. In theory, you think that, you know, as Nico showed, you write some code, you run it, and then something amazing just going to happen on your screen. But in reality, it's more somewhat like this, right? So out of 10, your code probably doesn't run. And once you finally got it running, it shows something random you don't even understand. So this is the thing that we don't talk about. Like, I show you one map, you think it looks great, but I might spend like a day or even a week working on that map just so that it brings you something to your eye. So I would always describe this making visualizations, it's a test to failure. We're starting by drawing some sketches. We make some mockups, drawing pretty images on Photoshop or Sketch. And then we make prototypes. We build 2 or 3, we run it by the PM, they hate one of them, and then the designer hate the other. In the end, you probably have to run through it again. When finally one of your prototype is good enough to be built, we put it into production. But that's when you're lucky. Most of the time, you probably just get stuck in this infinite loop where you always have to go back to start from the scratch. One example I like to show about this painful process that I made. So that's like when we first launched Uber Pool, which is probably 3 years ago. Our head of economics come to me saying, hey, we have all this Uber Pool data. Can you make some visualization and tell us a good story about it? So I look at the data and I think the theory is pretty simple. When you use Uber Pool, instead of using 2 cars driving two passengers, we just send 1 car and pick up 2 of them and drop them off one by one. So if you compare these 2 different methods, one with Uber Pool, one without Uber Pool, you know, you have on the one side only 1 car on the road, on the other side 2 separate cars on the road. And of course, using Uber Pool is going to have less cars on the road, it's going to provide cheaper ride and more efficient. So if that's my hypothesis, all I need to do is to do some visuals and compare using Uber Pool, people using Uber Pool, and then, you know, without Uber Pool, people will ride separately. So that's what I did. I gather 1 day of Uber pool trip. I ran them through OSM engine and gather 2 separate trips just to simulate if those 2 people didn't take single rides, they take 2 rides instead, what would the map look like? So I go on to do my first try. I use D3 and Canvas, just brutally drawing all the lines on the map and then somewhat animating them. And then the result is not very exciting. In fact, it doesn't tell me anything. Like they almost look identical. There's no sort of differences between these 2 different approach. And then I got frustrated. Okay, I thought it will look nicer because imagine on your left side, you actually have twice as many trips as you have on the right side. So the map should tell me something. So maybe it's not line, maybe I should just draw points. So I go back, I turn all my data into points and then sort them into QGIS, drawing all the points on the map and trying to compare. And as you can see, this doesn't tell me anything at all. They all also look very identical. And then I think the problem here is that when I overlay 10 points on top of each other versus 20 points on top of each other, and the visual part, there's not going to be much difference. You're just going to get this one solid color that might vary a little bit from each other. So maybe that's not the right approach. I shouldn't just expect when things overlapping on top of each other, they should look different. So I go back again for my third try. I think about what is this one major number that I want to reflect in my visuals. And the one major number that's varies is actually the number of cars on the road. So what if I calculate for the whole day every 5 minutes, how many actual trips are passing this one single road segment, and then mapping that number of trips to a color, and then use that color to dye to paint that road segments, which reflected back onto the trip itself, maybe it will show me the difference. And this is the result. I was really excited to see this because this is exactly what I tried to look for. I tried to look for different traffic volumes at difference when people using 2 different transportation mode. And by actually calculating the traffic and then drawing them back to the trip, I got this result. And then when I compare them next to each other, you can see there's obvious visual difference. One doesn't have that much of yellow, high traffic volume. The other has a lot of yellows. Okay, so this is what I got for my third try. And as I always do, I made a video about it. So animating 1 day Uber pool trip, on the other side, animating when people travels differently using separate trips. So this is very obvious that you can see when people travel separately, you create a lot of traffic on the road. When I showed this to our head of economics, they were like, he's like almost, oh my God, this is too good to be true. But that's actually what happens. So it's not like the data isn't there. It's just you have to find the right way to tell the story. You have to find the right visual representation to encode to find the insights inside the data. So that's a funny practice, and it took me 2 weeks, as I didn't tell you. But like almost every each try, I was like, okay, I'm just gonna give up. There's nothing there. But I suffered through it, and then I made something, and then it turned out to be great. So what I wanted to say here is that, as we did many iterations in this finding insight from data process, maybe there's some tool that we can build, which came to me later. Maybe there's some tool I can build that provide me all these different functions of looking through, apply different filters to my data, choosing different visual representations, and then embed and then encode numbers with different visual channels. So basically, that's why we built this tool called Voyager. So Voyager is a tool that can take a bunch of data set, location data set, and then turn it into different layers, apply different visual channels to it, and help people to explore geospatial data and find interesting story from it. So yeah, we built Voyager for fast visual exploration of millions of location data in the browser. And then Nico just showed some image of it. So needless to say, because it's built on top of deck.gl, you can encode like couple 100,000 millions of points and then do real-time on-the-fly aggregations, filtering, just so that you can very fastly test different visual representations and see what to gain insights from it. And yeah, this is the interface of it. I'm going to go in right into the user flow. So when the standard user flow is you throw in your data set, it could be CSV or GeoJSON. And Voyager provide you different sets of filters based on what's actually in your data set. If you have numbers and numerical data, it will give you like a range slider. If you have timestamps, it will give you a time slider, so on and so forth. And with the filter data, Voyager provide you a bunch of the different layer suites, like the ones Nico just showed, like scatter plot layer, arc layer, hexagon layer, and all the options are how you can encode numbers into visual channels and then draw the map for you. With that help, just one same single data set, I can create all different, this type of different diverse visualizations by interact with Voyager. Okay, demo time. Actually, it's a video demo time. So I got a couple of 100,000 trips from our database, total of 200,000 trips as a CSV format. And as you can see in this CSV, you have some column that looks like a timestamp, a datetime. You have some column that looks like a geo pair, like begin trip large, begin trip long. Yeah, and then you have some column that has like numerical numbers, such like trip fares. So what I did is I just throw it in Voyager. And because I have the trip start and trip endpoint in my dataset, Voyager automatically recognizes as a point, and it will throw a point layer for you. So without too much work, you already have this like layer of points, scatter plot points of all the trips that begins and end. And then the blue ones is all the end of trip, and the yellow ones are all the trip starts. And bear in mind, this is 200,000 trips with double number of points, which is 400,000 points. You can render in a browser without much lag at all. And after that, like the main of this practice is to try to find something from the data. So the answer I'm looking for here is there any difference between the way that people travels in the morning or in the evening? I mean, of course they are, but how do I show it? So what I did is I applied a time filter to all my trips. I filtered the video didn't play. Okay, so I applied a time slider filter to all the trips. So I filtered down a day of trip to just a couple of hours in the morning, 7 a.m. to 10 a.m. I said I'm filtered down. Anyway, so you can see here. You can see here it's very obvious that since the blue dots is all the drop-offs and then the yellow dots are all the pickups, in the morning in San Francisco, all the drop-offs are kind of concentrated around the Soma area, the Montgomery Street and the 3rd Street, because that's where from Caltrain to downtown. And all the yellow points are like around the surrounding areas like Marina, Mission, Nob Hills. And I did the same, so this is the morning, and then applied the same filter, but to the evenings. And then I got this image. Like it almost like took it, right? All the patterns like completely reversed. In the evening, you have all the pickups in downtown, or the yellows are the downtown, and then the blue ones are where the yellow used to be in the morning. So I was really happy to see this. And then bear in mind, this just by one like swap in a slider, and you can already filter it down your data to draw this kind of maps. And then I went out to explore. So what if I want to link the start and end of my trip? And will that show anything? So remember, we have this arc layer. Arc layer is created by just selecting the start of a point as a start and point as an end. Okay, let me turn off the, the other points layer. So yeah, there you go. This is just all the trips, the linking itself. I mean, you don't see much. So we built this like interaction called brushing. With brush, you can move your mouse and then highlight the trips that only start and end inside the region of where your mouse point at. And it's pretty cool because when I mouse over, that's like Oakland Airport, and there's a lot of trips starting from there. And then you can see most of the trip we have is just like downtown to the airport because there's very thick branch down there. And with this, like, this interactions all happens on the GPUs. We write them into the shader. So we're not using JavaScript to filter data on every movement. So like, it's all calculated inside the shader. So that's why it's so fast. And then so just by looking scattered data, it doesn't show aggregated result. So you can use, we build this, we also connect layer with a deck.gl hexagon layer to show heat maps. So what I need to do is just selecting my heat map layer and then selecting the points I want the heat map to aggregate. So this will perform on-the-fly binning, bings all the points into hexagon cells. And then we can also use the tool to change resolution of the cell to make it a lot more fine grain. And then change different color palette because, who doesn't like purple? And of course, everything looks better in 3D. Once we add the third dimension to our heat map, we add the height, connects embed the number of points to the height of the heat map. I want to pause here. You can see like right here is where you have all a lot of trips happening. Those are all the airport. And then here, I think it's Caltrain station. So we immediately see this like anomalies in our data set where most of the trip just happen from transportation hubs. But what if we want to filter down hide those top anomalies to show more patterns and within the lower distribution breadth, we can just by scrubbing the percentile slider. This will hide the top percentile bins and recalculate the color for the lower percentile bins and shows you more patterns underneath there. With that all being shown, now I'm going, what if, like, 2 years ago I have Voyager, or I still have this 2 week of painful exploration. So I, just of curiosity, I actually did it today. I find my old data set where I used to create Uber pool visualization. I just throw it into Voyager. So first of all, I'm plotting the same point cloud with all the GPS points. And again, don't see anything, but as soon as I turn on the hexagon layer, where I actually aggregating the points, you can see it's very obvious the highlights are around the highways. And then when I turn on the height, where the density or the aggregate value is a lot more visible. So this is when people taking separate trips. And then it's very interesting where you see along a couple of roads, there are a lot of, those are the roads that most car take, those are highways. And then even the bridge, actually not that many, because I guess at that time you can't really pull to East Bay. And when I compare it, it's like, this only takes me like 5 minutes. I just draw this, use Voyager, I draw this 2 image with 3D hexagons. And since Voyager also allow me to filter through time, I try to recreate my any road traffic animations with my time filter. I dropped all the GeoJSONs I once calculated into a path, and then color each road segment by number of traffic, which is already encoded in Python, and then I got this image. Since later on, I filtered this. This is all the trip in one day, but when I filtered down when I filter down by time, you know, and actually animating through it, I have this, I immediately create this animation, how road traffic changes throughout the day. So what is behind Voyager? We use React, we use React Map GL, and we use deck.gl, which Nico already showed you. And those are like, those just three simple libraries that we put up together just so that we can quickly draw maps and explore geospatial data. And then with that helping us, you know, is we can create more and more geospatial mapping visualization that actually tells interesting stories about the city. You know, there's only one Shan, so if you ask for like a video for your city, you used to just give me a week, now you can only give me 2 days. All right, that will be it. Thank you, everyone.